Hello everyone, welcome back. So what's we're gonna do in this series of the video So in this video, I want to turn this sum as it is equal to e to power ai plus e to power ib into multiplication. Okay, I want to turn the sum of two complex number into a multiplication. So how do I do that? Well, so you can write like this. You can start by saying, so s will be equal to e to power ai plus ib. I will divide both sides. I will divide by e to power ic times e to power ic. So you will get e to power ic times e to power ai minus ic plus e to power ib minus ic. Okay, like ic is inc, not like ic, like I see you. Anyway, let's keep on going. So this is gonna be e to power ic times then we use this bracket e to power I should use the other one, my bad, minus c plus e to power I b minus c times e minus c. Okay, and if you use the Euler formula, again, called the Euler formula is e to power ix equal I sine of x plus cosine of x, right? So if you use the Euler formula, you get e to power ic times I sine a minus c plus cosine a minus c plus I sine b minus c plus cosine of b minus c. Okay, wonderful. Okay, so now I want to regroup it. So I get e to power ic times I times sine a minus c plus sine b minus c plus cosine of a minus c plus cosine of b minus c. Okay, so what do I want? I want to choose c. I want to choose c in a way that the imaginary component disappear. Okay, how can I do that? I set the imaginary component equals 0. So sine a minus c plus sine b minus c equal 0. So this part I highlight in yellow. Okay, so in order for this to be equal to 0, so you say sine of a minus c will have to be equal to negative sine of b minus c, and negative sine b minus c is, you can put negative sign in, so you get sine of negative b minus c, or sine, if you phone it out, you get c minus b. So sine of a minus c equal to sine of c minus b. So a minus c have to be equal to c minus b. Okay, so you have this term equal. So you can solve for c, right? So you can add both c both sides, you get a equal to c minus b. So choose c is a plus b. So your c is just a plus b over 2. Wonderful, this is your c. Now, what you can do is you can plug in c. Plug in c into, let's call this equation 1. Yeah, now we can plug in c into equation 1. So we have what? We have s equal to e to the power ic times I is times 0, because the sign, the two sign plus together equals 0, because that's what we want. We already set that equals 0, plus cosine of A minus C plus cosine of B minus C. Okay, so the sum is just gonna be e to the power IC times cosine of A minus C plus cosine of B minus C. Okay, so let's go ahead and replace C with, so C, recalling C is just A over 2 plus B over 2, or A plus B over 2, whatever work. Okay, whatever work for you. So C, I can replace it now, so e to the power I times A plus B over 2, and times cosine of A minus C is A minus A over 2 minus B over 2, plus cosine of B minus C, which is B minus A over 2 minus B over 2. Okay, so your sum is going to be e to the power of I times A plus B over 2 times cosine of what? Of A over 2 minus B over 2 plus cosine of B over 2 minus A over 2. And you know that, you recall that cosine of x is the same as cosine of negative x. Okay, so that being said, you can flip the sign of cosine, which it have the same value. So e to the power of I times A plus B over 2 times cosine A over 2 minus B over 2 plus cosine of negative B over 2 minus A over 2. Okay, I'm gonna use this bracket, it's better. Okay, so it will be, your sum is gonna be e to the power A to the A times A plus B over 2, I times B over 2 times cosine of A over 2 minus B over 2 plus cosine of A over 2 minus B over 2. And so you get, your sum is going to be 2 times e to the power I times A plus B over 2 times cosine of A minus B over 2. Okay, this is going to be your new sum. And this is going to be equal to e to the power IA plus e to the power IB. Okay, so this equation is extremely useful, especially when you solve for partial differential equation with different boundary conditions. I think this equation will help. Okay, but we'll discuss how it's be helpful later. Right now, I really appreciate everyone to listen to the derivation and follow. I hope you have a good day, good night, or whatever timeline you're in. Okay, I'll see you in the next video. Bye bye.